Hi, Brian. Thanks for
Hello.
joining. Yeah, so we have Brian with us, the author of Amazon bestseller Quantum Boost Using Quantum Computing to Supercharge Your Business. He's a He's the author of four published books on AI and quantum computing. So he's always active in LinkedIn, always posting about the progress in quantum computing. Whenever you need to know anything about any new things about quantum computing, I suggest you to follow him. He's always helping others to transform to quantum computing. And thanks a lot for joining, despite it's very early morning there. You actually joined 10 minutes before. So thanks a lot. So the stage is yours.
Thanks very much. And first of all, I want to congratulate everybody who is in this session today on this journey with quantum and taking the time to learn about models, algorithms, kernels, the fundamentals of quantum itself. When I talked to the organizers about this session, I really wanted to focus on the quantum journey. And everybody's quantum journey is quite unique. And in my case, I was a lifelong banker, 25 years working in a major North American bank. And it was a fascinating period of time where quite often my role was the liaison from the business team to the IT team. And quite often what I would learn from that aspect was the importance of bringing those two worlds together. And quite early on, as you identify business problems, that has become my mission as it relates to quantum. When I think about the journey from leaving the banking world about 6 years ago, I had an incredible opportunity to retire and to think about those sort of next steps. Shortly thereafter, I thought, well, what would I like to do next? My opportunity was wide open, but I kept coming back to that business relationship with IT. So I thought, where are IT trending? And again, 6 years ago, where's IT trending? And I thought, well, it was artificial intelligence at that point. And I thought, well, where is artificial intelligence really focused in terms of its center of excellence? And at that point, it was the MIT, Massachusetts Institute of Technology. So I took their AI strategy program. And for me, it was interesting because the phone started to ring. People started to ask me, Brian, can you help me think about artificial intelligence in the context of my business? And so I started helping them develop artificial intelligence roadmaps, ways to think about their business problems as it related to artificial intelligence. And so that quickly started to merge with the world of quantum. And by that, I mean, I was attending conferences throughout the world. And let's go back about 3 years where the bulk of the people who were attending those conferences at quantum conferences were researchers, academicians. They were people who were vendors, but very little focus on the consumer side of quantum. And so as I started to talk to peers in the quantum world, they identified the same white space as I did, that consumers were not, at least at that stage of maturity, thinking about how they could use quantum, what it was. And so we started thinking about how do we fill this white space? How do we accelerate the adoption of quantum technologies, whether it's communication, computing, or sensing, cryptography? And so that was the genesis for putting together the Quantum Strategy Institute. Quantum Strategy Institute is a 20-person think tank, people from around the world, from all continents, who are focused on that mission of accelerating the adoption of quantum. So, harken back to the concept of this business problem. What's the business problem for quantum? The challenge really truly is, how can people understand, first of all, what quantum is and what depth do they need to go? Do they need to equate to the work that you're doing here in this program? Or is it a more broader distribution of talents? And once they've identified, what quantum is and to what level they need to understand it, well then, what benefits does it bring to those individual organizations? And in 2022, that's not necessarily clear still, where the technology is maturing, and we're starting to see use cases and applications. So back in 2021, I identified this and thought, okay, at least I need to produce some material that will get business people on the journey in approachable, more common sense terms. How can you understand all of these quantum type technologies? And once you do, how do you start bringing that into your organization? Now, fast forward to 2022, where I just published my second book on quantum, and that had a bit of a different tack to it, because in that area, we really wanted to get people to start thinking about, well, who are the leading companies? Who are those ones that are actually deploying quantum technologies in their business? And what's fascinating about that is that it's a journey. It's not simply buy yourself a quantum computer and store it in the back room. This is really much more about the nature of quantum being a cloud-based service, a licensable service. And what does that mean? It changes it from capital expenditure to operating expenditure. So I'm making sure people understand what that means. And then, leveraging all of the tools, you get not just, pure native quantum, but quantum inspired and hybrid and pure quantum. And how does an organization think about what makes the most sense for them? The most organizations today are actually leveraging quantum inspired. So that opportunity to take the intelligence from quantum algorithms and apply them in a classical or conventional environment. Companies like classic and multiverse computing are using those techniques with their clients. Banks, for example, auto sports, all sorts of different areas that they're actually getting incremental, iterative benefit from that quantum-inspired capability. So again, I'm looking at it from the business person's perspective. One of the examples that was given off the top about how often I am posting on LinkedIn, and frankly, I only post on LinkedIn when I'm inspired, but I'm inspired a lot. There are so many ways to think about quantum technologies. One of the examples is quantum will change the face of archaeology forever. And why do I say that? Organizations like the University of Birmingham have come up with things like the quantum gravity gradiometer. What will that do? It allows us to see into the Earth in ways that we've never been able to see before. So if you're an archaeologist who's used geophysics and history and various other techniques to find those settlements, those caches, now you can use a new technology that will allow you to see into the Earth. It's also so valuable for things like volcano forecasts and earthquake eruption forecasts. So there's some so interesting opportunities for quantum technologies. As I meet with different organizations around the world, they are telling me all sorts of interesting stories. I just recently met with a group that is focused on quantum cryptography. And the essence of quantum cryptography is that eventually we'll have quantum computers that break RSA type codes. Some people consider it inevitable. Some people think it's 10 years away. Regardless, there are techniques of harvest now, decrypt later, that bad actors are starting to deploy. So what can companies do to prepare? Well, there are various different techniques, whether it's post-quantum cryptography or QKD or one-time pad or quantum permutation pads that enable organizations to start to create that protection layer. But organizations, generally speaking, I would say about over 90% have yet to really contemplate the opportunities around quantum cryptography, let alone what quantum is. And so, the opportunity for me is to provide these examples in common sense, approachable language for individuals who are leading organizations. The other side, I guess, would say is that there are significant opportunities for people of all backgrounds to be involved in the quantum space. A recent post that I did spoke about the importance of women being involved in the quantum area, and that was just one of many sort of characteristics. Another one would be the importance of diverse backgrounds. As I said, my background is in banking. What's the benefit? Well, I understand those sort of key challenges that banks have, and whether quantum would be a potential solution for things like portfolio optimization. So there are continuing significant challenges. So in terms of the journey, you think about what I've just described, from going from a banker to an artificial intelligence specialist to a quantum specialist. You know, the world is evolving so quickly. How do individuals like yourself or even business leaders really manage to keep up? And, you know, one of the things I focus on constantly is this issue of quantum curiosity. I am very curious about, you know, the techniques being used, the opportunities that are available in terms of those business cases or applications. And so every day there's some new breakthrough of some kind in the quantum field that provides inspiration for further curiosity or further discovery. And so I reach out to people all over the world just to try to understand, is that discovery real? So one of the things you may have heard about is this issue of hype, and it can be very real. As I hearken back again to the artificial intelligence days, not only do people have a challenge with understanding what was inside the black box, but also the issues of bias and error, and, you know, what does this mean to my brand if you make significant errors or have significant bias? Well, similarly in the quantum world, and then the issue of winters. Artificial intelligence had at least 3 winters where significant investment was being made, and then it declined, and then significant investment being made, and it declined. And again, the reason was because there wasn't any results or significant enough results or returns. So part of the mission of the Quantum Strategy Institute is try to ensure that that quantum winter doesn't actually occur. How can we actually work through the elements of investments versus hype versus actual applications? And so that's part of my mission, to actually continuously provide people with understanding of what applications are actually out there. And another example, I guess, is the example or the application of communication. Some people may have heard about the British Telecom, Ernst & Young, Toshiba, where they have created a closed quantum internet between 2 facilities. This is also being done between labs, and we're seeing it between cities. So what are some of the dynamics? Dynamics are a concern for security, the importance of data throughput with that layer of security. And, you know, when a business is thinking about the pipeline, the actual optical fiber layer, how can they ensure that that is secured as well as the point-to-point? So communication is a key area. When new developments are occurring in the quantum space, there's always a great deal of skepticism about whether it's covering off all of those areas: risk, cost, scope, the ability to actually integrate with your existing communication, or with your existing conventional systems. And so the opportunity is to have business people who understand those dynamics, regardless of the technology, to bring that analysis forward so that they can think about where does quantum fit. Because as you can imagine, if you're running a payroll system today, or you are running an email system, today's conventional computing offers the kind of benefits that you need. But if you're looking at a problem that would take you 10,000 years to solve, there is an opportunity to start to work in the quantum space to see if that capability will address that problem. So whenever I talk to people in the C-suite, it's less about quantum powered. It's more about what results can you achieve first as it relates to your key business problems. And then we start talking about the solutions. And that's something that will have to be part of the storytelling process for everybody involved in quantum. It is just so vast in terms of the technologies and the players, and trying to understand all of that. So, when we think about the next steps for the quantum journey, we need not only PhDs, physicists, but we need storytellers. We need people who understand operations. We need people who are thinking about the business problem and how that it might be associated. One of the examples I quite often draw on is the Port of Los Angeles, where during the supply chain challenges, there were lineups of trucks waiting for cargo to try to be offloaded. Well, as a result of their analysis of the Port of Los Angeles with a company called D-Wave, they were able to significantly reduce the amount of movement within the yard on a daily basis to be able to address part of that challenge so that the delay period was significantly less. And so what I would encourage you to do is to look for the sources of information around quantum that you trust. Those sources that are not promoting the hype, but looking at it as quantum from a balanced perspective. Thinking about organizations like the Quantum Computing Report or the Quantum Insider, the Quantum Strategy Institute, areas where we are looking to make sure that we have an incremental, iterative approach. It's okay to make a mistake and then learn from it and then move on. Not everything has to be North American colloquialism, a home run. And it's just as important or significant to be able to drive the development of the quantum journey in short steps as it is in the breakthroughs. And that's why I'm very excited. I'm going to give it just a couple more minutes of my introduction, and then I'll pass it back to the host if there are any questions. That we have this sort of balanced approach to the quantum journey so that we continue the investment that's being made, that we continue to impress upon business leaders and investors the value of quantum capabilities so that we can consistently move forward. The next decade for quantum technology is going to be so exciting, and I think that the people who are on this call are going to be the beneficiaries and certainly pioneers and drivers. And as you take your education, your learning into the future, build out that robust skill set that gives you the ability to tell the quantum story, if it's simply just within your project or within your organization. It's an exciting time to be part of quantum, and I'm thrilled that I have the opportunity today to talk about this. I'm going to toss it back to the host to see if there are any questions.
Hi. Thanks, Brian. Such a great talk. I was actually wondered about knowing the progress in archaeology. Using quantum computers and using quantum technologies in archaeology. That was very new to me. That was great. So, people, you have any talks? I think any questions? Maybe most of the people attending this is and more from undergraduate background. So do you have any advice for
Sure.
them, like how to
Yeah.
start their journey?
Yeah, absolutely. One of the things that I often get when I talk to large groups of people is I ask people in the audience if anybody has an arts background or a history background or a background in business. And the reason, and lots of people put their hands up. And I say, well, that's fantastic. And the purpose of my question is to understand where people are coming from their undergraduate backgrounds. What can they contribute? The people, particularly when I had large teams, I would hire in people from an arts background. And the reason I would do that is because those are the people who ask the why questions. Quite often in technology, we think in a very linear sort of approach. We actually try to, develop ideas once in sequence. And quite often people from other backgrounds will ask the question, why are we doing this in the first place? And that's okay, because that gives us the opportunity to understand the broader perspective. And so, regardless of what background you come from, there's always an opportunity for you to provide value. Did we lose the connection?
Then have a question.
Okay, go ahead.
Yeah, say for example a business problem. Not all the problem are amenable or it's efficient way of solving through AI, right?
Exactly.
Similarly, not all the problems may be amenable for quantum computing. So,
Correct.
what are the characteristics while picking defining a problem, business problem for quantum? What is that you look through?
The very first part of the conversation, and particularly a lot of the business development people in quantum will have this conversation, is what problems do you have that cannot be solved with your conventional computing? That's sort of driver number one. Even if you have all of the data within 10,000 years, you could never get to a certain accuracy level or attempt. So, for example, portfolio optimization in financial institutions, real-time benefit translates into millions of dollars, but the data is too vast, takes too long, your period of time may be running it once a day versus, in real time, which would be just staggeringly difficult. So the first question really is this a problem that's just not solvable today by classical or conventional computing? Then the next question becomes, do you have the infrastructure to actually address this problem via quantum technology? And that can be whether you have a team inside your organization or you have trusted vendors who can accomplish this. And then finally, the question around integration. How important is the ability to make this a seamless interaction, whether you are, if you're running your traditional systems and this problem requires you to bounce back and forth between a classical and conventional computing capability. Do you have that seamless sort of connection in order to address the problem? And so, I think those are three of the key areas that organizations need to think about when they want to introduce quantum.
Thank you so much. Very well answered.
You're welcome.
I have one more question about quantum winter. What were you talking? So do we I see the quantum computing, for it to be successful, there needs to be adjacent technology to be improved, right? So will the current state of technology, be it data like data IoT or whatever way we get the data, and cloud computing, AI, are we in, is it good enough to support the quantum computing? I know some problems are already being solved with quantum computing, but when we are talking of 5 years down the line, when the quantum computing is very mature to take up big problems, right? Do we have other technologies well developed? Do you think? What is your perspective on it?
Well, your comment about good enough is exactly right, because if we are looking for the penultimate fault-tolerant, universal fault-tolerant quantum computer, that's years away. But are there things that we can do that are simply good enough today that integrate IoT, 5G, AI, in some form? And while it may not be a massive improvement, where organizations are thinking today is, okay, what incremental benefit can I get from today's technology? And in parallel, how can I set up my organization for the technologies of tomorrow, because they are expanding or improving so quickly? And I, as an observer of the industry, the pace at which quantum technology is advancing was significantly more exponential than happened in the artificial intelligence world. And so the importance here is there are plenty of applications, plenty of technologies that exist today that we can use that are of incremental benefit. And so the work that you're doing today here, will be applied tomorrow, but not necessarily to the same degree of maturity 5 years from now. But that's absolutely okay. We need that sort of good enough for today to keep providing that incremental benefit for investors, for business leaders, for inspired PhD students to continue to work.
Thank you.
Any more questions? Also, I'd like to know, so in which industry, in which sector would quantum will bring in more opportunities and more benefits?
It's a great point, and it's really changing. So the areas with the greatest advances so far are in financial services, in telecommunications and media, transportation. Believe it or not, which is a traditional laggard, has quickly found numerous projects, particularly in optimization. So financial services, telecommunications and media, and transportation are the leading areas today. Where a lot of people see the biggest opportunities in areas like life sciences and manufacturing and material sciences, where we can start to address not just the small molecules, but the large molecules with significant numbers of atoms and infinite possibilities in terms of the marrying of various different component materials. Certainly, if you take that one step further into the area of health, and I don't necessarily mean healthcare. I divide out healthcare and life sciences, healthcare being the hospitals and our operational areas versus the significant scientific work being done in life sciences. And the understanding of the human body and the personalized medicine, personalized diagnosis. Those are areas that are being actively addressed today. So, then I would say the groups towards the end would include areas like healthcare, some areas of manufacturing, groups that have yet to understand it. In the last 6 months, I would say the world of governments have leaped into the first grouping. And I don't mean how governments are actually using quantum technology within their departments, more so the support that they're giving, particularly around cryptography and chips. So, various different countries thinking about the importance of securing data, privacy, their employees, their customers, their communications. So governments are really starting to put significant effort towards that area. So it's very interesting to see. I hope I answered your question.
Yeah, definitely. Thanks a lot for joining this early. Does anyone have the question?
I had one last question.
Yeah, sure, please.
And you had a very fantastic career, like banking to AI to quantum computing, right?
Yes.
I know you have disrupted yourself, right? Build up your expertise and become an expert, and then you're an influencer. So, if someone is starting right now, like we are all, right? How do you advise to go ahead, pick up the skill sets in quantum computing, be it whatever field, like you said, right?
Absolutely.
And become an expert and become an influencer, so that down the line we can use these skill sets to influence the organizations where we are to build a fantastic applications.
So,
Basically, want to know your journey and any tips you want to share with us.
sure. I'll be very honest. When I started down this path in more advanced technologies, I did not know which niche or which area I really wanted to devote my time to. So I spent a great deal of time with free resources like YouTube, just to actually explore these various different areas so that I could then narrow down my focus, and where I was making investments in education, I was locked in, laser focused on the area that really inspired me. So, artificial intelligence and strategy were the ones that really got me excited at the beginning. So, leveraging those free resources to really narrow down my area of focus, making my educational investments in areas that I was very, very inspired by. And then, as I started to do that, bring together a network of individuals, people who were inspired by the same kinds of things, because what that allowed me to do was take their energy as well and really think about areas of even more specific interest. So, narrowing down my field to quantum strategy, which I've really been focusing on. All of those to me we're all human beings, and we need to be inspired. We need to be motivated to put in all of that effort and commitment. And for me, that was the path that made the most sense. Today, I'm surrounded by incredible people making incredible progress, but I also have the balance that says not everything is going to work. There are 750 quantum vendors in the world now, and not all of their solutions are going to work. There are 10 different modalities in quantum computing, and not each one of them is going to be the eventual successor. So, really taking that inspiration and balance and thinking about where can you apply it. There are so many areas to be able to apply what you've learned during your quantum journey, that it's like there are more synapses in your brain than stars in the universe. There are so many different possibilities, but you really need to be laser focused on something that you're inspired by, and that you've added new incremental skills or experience or knowledge along that path. I know that in my environment there are lots of people who have much greater understanding of Gaussian boson sampling, or quantum algorithms, or the proper cryptography technique, and that's okay, because I'm operating in my space, and I know that they're available should we need them. So that has been my journey, and I hope that's an accessible journey for the people who are on this call.
Thanks for sharing.
Welcome.
Sir, I wanted to ask whether are there things that classical computer can do and quantum computer cannot? And if that's the case, why can't quantum computers replace classical computers entirely?
Yep, so that's a great question, but it's really a point in time question. So there are things that classical computers can do today, and we've seen a few examples where you have things like Rainbow or Psych, cryptography mechanisms that can be broken by a laptop PC. So there you go. At this stage of maturity, quantum cryptography is not necessarily in all ways better than classical. You also have a point in time where it's much more cost effective to use traditional, classical, conventional computing for the problems that you have to solve. But here's the challenge, that as we identify these NP hard problems, whether it's space navigation or large molecules that we cannot solve today, that's where even the greatest advances in supercomputing will never be able to address. And the question is how quickly we'll mature along that scale, along that journey, so that we have the best possible combination of classical and conventional. People hear about Moore's law and whether that's continuing. The advances in traditional computing, we need to have those advances to continue. We need to be able to say that, we have supercomputers that are very effective at solving certain problems. But there just are problems that classical computers will just never be able to solve, not in thousands of years, just because they're completely different techniques of binary versus qubit technology. I don't take an either or approach. I think it's important that we acknowledge the benefits of both.
Thank you.
I hope
I think I've gone over my time.
Yeah, I hope you have finished the questions, and such a wonderful wonderful talk, very insightful, starting from archaeology to finance to medical field. You have explained the journey, how to start, and everything. Thanks a lot for joining, and thanks a lot for joining, and wish you all the best. Please follow Brian Lenahan on LinkedIn if you want to get more insights into quantum computing and the progress and the new trends. So once again, thanks. And once again, thanks for all of you joined here today.
Right. Thank you, and good luck to everybody.
Yeah.
Thank you.
Thanks a lot, sir.
You're welcome.